Hello, everyone, and thank you for joining us for today's session. My name is Iskia, and I am one of the event planners for the Redmond Reactor Space. Before we get started today, I've got a few things I'd like to go over. If you could please take a moment to read our code of conduct. And basically what that says is that we seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but ask that you please be mindful of your commentary, remain professional, and please try to stay on topic. Useful links will be shared throughout the chat, so keep an eye out for that. And this session is going to be recorded and will be available on demand in about 24 to 48 hours on the Microsoft Reactor YouTube channel. That brings us to today's session. It's scheduled to run approximately for 1 hour, and there will be time for questions throughout. And with that said, I will now hand it over to our speaker.
Hello, everyone. Excited to be back at the Reactor, and I've got a lot to show you. This isn't the first time I've spoken at the Reactor, and I've got a surprise. I've got a surprise guest also who's going to come on at the end and introduce a new update to the reliable web app pattern. And we'll see Nick a little bit later. So what are we going to discuss today? We're going to discuss getting to the cloud, migrating your workloads to the cloud in a very easy and also stable and reliable way. And we've just done an update to the reliable web app that enhances the security and also increases the robustness of these applications. We've got a new application. We're going to showcase it today. I've got some slides. I've got some demos, and then we're going to see if we can break the reliable web app. It's reliable, so it shouldn't actually break. I'm going to hit refresh a couple of thousand times on it, and let's see what we're going to do. Okay, so no more talk. Let's get on to the slide. So the first thing you're going to see here, it's a nice little Far Side cartoon, and it says there, Andrew is hesitant, remembering his fiasco with the car of straw. And we don't want to create straw applications on the cloud. We want something robust. So before I start, let's just go through who I am. My name is Rory Preddy. I've got brown hair. I'm wearing glasses. I've got a green shirt on. And I'm speaking to you from Johannesburg, South Africa, in my home office. And I'm a developer advocate. And advocates reach out to everyone and help partner with our product teams. And one of those product teams is the application patterns team that I've partnered with to go through the reliable web app pattern. So in this session, we're going to introduce you to the new reference architecture for the reliable web app pattern. And we're going to look at the key principles for the architected framework, simplified deployments using a dev container and the Azure Dev CLI. And then we're going to look at diving into the retry circuit breaker and cache aside pattern. Well, at the same time, you don't want to make too much changes to your code to get onto that. So we're going to look at how you can do this without having to have too much code changes. So first of all, like, what do you mean, Rory, going on to the cloud though? So the cloud really follows a certain life cycle where you've got your legacy into your application, and then you're going to converge, then you're going to modernize, and then you're going to scale. So what we're talking today is about converging, which means that you've got your application, it's sitting on-prem, and you want to move it over to the cloud though. And then once you have that, we're going to modernize, and we've got Nick who's going to come in the end there, who's going to discuss very briefly about the modern work pattern that is the next stage of this enterprise web app cloud journey. So yeah, well, the go-to prescriptive guidance for this Java web apps and the .NET web apps is the reliable web app pattern. It's actually a pattern of patterns. And what it does, it really takes a lot of principles and takes each one of those principles and kind of cooks in a nice application that you can take off and reference to take your application to go to the cloud. Now, the focus really, using the well-architected framework, is managed services, infrastructure as code, and role-based security. Now, once you have that, you can see the diagram that we have here. We focus on cost optimization, observability, and ingress security to ensure a robust and efficient application and cloud adoption. Well, that's great, Rory, but I need a reference application to do that. And we have the reference application. Now, recently, we upgraded the reference application for the reliable web app, and we enhanced the security and scalability, and we call it Contosa Fiber. What Contosa Fiber really is, it's a nice in-depth application. And we're going to talk about a fictitious company that wishes to converge to the cloud. And their current setup includes an employee-facing app for managing customer support cases, which is on-premise. It's a monolithic Java web app built on Spring Boot. Their challenges faced includes extended timelines for building and shipping new features, and the difficulty scaling application components under high load under the adoption phase. They can't converge to the cloud. So we're going to look at what they need to do to converge to the cloud and using those patterns of patterns and how they can go there. So Contosa Fiber really needs to expand their on-premise application to reach other regions. Now, to meet the increased demand of their web app, they need to establish some goals. And one of those goals is 99.9% service level objective. So that means that, yeah, they're not down. They're down for like 4 hours a year. And they need to do that also with good DevOps practices. They need to create cost-optimized environments. They need to improve their reliability and security. So they determined that their on-premise infrastructure wasn't a cost-effective solution for scaling the application. So they decided they're going to migrate the web application to Azure. And it's the most cost-effective way to achieve the immediate and future objectives. So here we have the SLA that you have, and you see it combines the SLA. Now, this is the development environment. Now, we also have a production environment, which is a little bit higher, because then once we have that, then you have your databases that can scale, and then we pop databases and the application on multiple regions, though. So we're going to talk about, in this session, the development environment. You can see that you've got front door, eventID, app service, Redis cache, Postgres, and Key Vault. And the combined SLA for the development environment is 99.72%, though. So that kind of meets their SLA for the development environment, and then for the production environment, it's 99.99%, though. Sorry, 0.9%. Sometimes I get confused with the nines. So what does this application actually look like? So we've got our architecture here. So once we finalize the critical path for the SLA, we can look at the architecture deployment. So the session covers the development environment, which is a simplified version of the production environment. The production environment aligns to a hub and spoke network architecture to centralize common resources. And this network topology provides cost savings, enhanced security, and facilitates network integration, both platform and hybrid. The full production environment, we're not going to cover it today, but it is available in the reference architecture, in the URLs that we're going to provide. So you can go in there and you can do a cross-region failover if you want to, though. So first, the user traffic is directed through Azure DNS and routed via Azure Front Door. And it's integrated into the Azure Web Application Firewall. So this setup ensures load balancing and security, while role-based authentication is managed by eventID. The request then reaches the app service plan, where access restrictions block unauthorized public internet access. Last thing we want is someone just like, waltzing into the application who shouldn't actually be there. The application logic runs on Azure App Service. Now, in further applications, we're going to see how to containerize it, and that's something that Nick is going to briefly cover a little bit later. But you want to remember, converge to the cloud, take what you have, which is Azure App Service, and then you want to modernize it and then scale it accordingly, though. So the application then interacts with Azure Database for Postgres Flexible Server, very cheap, very powerful for data management, and Azure Cache for caching, meeting performance and availability standards. Try to say that 5 times fast. And monitoring and logging are handled by Azure Monitor, Log Analytics Workspace, and Application Insights. Now, these provide real-time insights and diagnostics as required by the SLA. Now, Microsoft Entra ID aka Active Directory, manages the identities, and Azure Key Vault secures sensitive information, safeguarding data. Now, if you remember in the beginning, I said enhanced security. So we're going to cover managed identities. I'm going to show you exactly how to do that. And it is such a huge weight off my shoulders to be able to do that, because I don't have to remember passwords or worry about the wrong person accessing the certain services. So we're going to go through that in our demo, and we're going to detail that in detail. Now, every time I push to the cloud, I don't want to have to go, okay, what did I do? How did I do that? I want to use infrastructure as service. Now, Contosa decided to use Terraform templates to enhance efficiency, maintain consistent environments, reduce errors, and streamline infrastructure management. What does infrastructure as code do? It automates your setup, ensures consistency, and eliminates manual errors by codifying the configuration. Now, the mutable infrastructure replaces old resources with new ones, minimizes risk of configuration drift. Now, the modular design also uses reusable Terraform modules for consistency, streamlining maintenance across projects. Now, the state management tracks infrastructure state for precise adjustments, ensuring deployments accurately reflect the defined code. So I don't have to worry about like a developer or a admin pushing the changes, and then suddenly I go, how did that land up there? It's checked into Git with the project. So you get the added safety and security that you know exactly what has been deployed. So once we have that in the cloud, let's go through exactly what are 3 essential patterns that we're going to discuss. Now, there's 3 essential patterns, only 3, and that is the retry pattern, the circuit breaker pattern, and the cache aside pattern. Now, these patterns help create a robust, resilient, and high-performing application capable of handling various challenges in a cloud environment. So let's first go through to the retry pattern. And Contosa plans to use the retry pattern to enhance the reliability of the applications in the cloud environment. And the retry pattern handles transient faults. So transient faults is like blip, 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 blip. A blip goes in your network or something, and maybe like I'm in South Africa, so a submarine can actually go over our network cable and go, something went wrong, reroute to something else though. And the transient faults resend failed requests until the service is back up. It's not about mindlessly resending requests. It includes a delay or backoff between retries to allow for service recovery. The backoff can be fixed or increased exponentially based on the configuration. So you can see in the example that we have there, we have the application, it hits the hosted service, it tries, it waits off a little bit, and then it tries again, and it eventually comes through though. But what happens if the service is down like completely? And what do you do though? So then you use the circuit breaker pattern to and Contosa plans to use this to adopt a service state and provide efficient fault handling in their application. Now, the circuit breaker pattern complements the retry pattern by providing additional fault handling. It retries caused in case of a temporary issue and acts like an electrical circuit breaker. So if you go into your house and you've got that circuit breaker, your box, I've got mine in my kitchen, and if I have something, let's just say my toaster trips my house, I can't switch the toaster on. I have to go to the circuit. I have to switch it back on. And if there's a problem, I have to go and replace the toaster though. So it's the same with the circuit breaker. The circuit is closed when running smoothly, allowing requests to follow through. And the circuit opens after a failure threshold, stopping requests to prevent resource wastage. It enters a half-open state after a time, allowing limited requests. Now, if the requests succeed, the circuit breaker closes. If the request fails, the circuit breaker stays open. We're going to see in a demo exactly how that works. And it's got like a cool-off period that we're going to actually test live on air to say, okay, cool, Rory's going to hit it a couple of thousand times. And once we'll cool off and the service is available, then we're going to come back to it and see, are you available again? So all of this is available with your code, and all you have to do is really annotate your code with some very easy to use Spring Boot annotations. So you can see here, these are the Resilience 4J annotations, and these enhance the reliability of Contosa's applications. Now over here, we've got the retry annotation, which is part of the Resilience for J library, and it automatically retries a call to the service plan service if it fails. And we'll go through the demo when we finish the slides, making it useful for handling temporary network issues or service availability. The circuit breaker annotation is also part of the Resilience for J library, and it helps build fault tolerance applications by opening the circuit and stopping calls temporary if the service plan fails repeatedly. Now, before I came onto the session, I was demoing and I was like going, okay, cool. I want to break the circuit and everything, but it's very hard to break the circuit if the retry pattern kind of works with it though. So you want to pair the two to handle transient and non-transient faults. So we added a feature to test all of this in the reference application by simulating a transient failure. The setting is called Contoso Retry Demo. It's included in the deployable code, and I've already got it set up to actually have the error, and it simulates the errors when the user requests service plans within the Contoso 5 application. And this editable setting determines the number of back-to-back errors before a successful request. In our example, if you have a value of 2, it generates 1 error after 1 successful response. It's disabled by default, and it's set to 0. Well, if you want to disable it or remove the setting. To use this feature to observe when the circuit breaker opens or closes due to failure thresholds. So how do we actually activate it? So first of all, we're going to click on the service plan links in our application. On the left-hand side of the Contoso Fiber application, this will make a query to retrieve a list of all service plans. So this is a CAMS application that actually goes in and says, okay, cool. It's kind of like a call center. And there you've got cases that you can log a case against a customer. So we've got our service plans here. And because we had activated the retry demo, the setting is set to 1, then the application will return an error. And we can go into the actuator and the settings here so we can navigate to actually go in and see the retry events. So in our example there, you can see get service plans, and we're throwing exceptions left, right, and center. Of course, if we're throwing exceptions, what is going to trigger? The circuit breaker. So if we go into that setting there, you can see there's a little bit of a long little metric there, but we can see that the circuit breaker now is open. So the circuit breaker now is transitioning to the open state. And when the failure rate of the calls into the downstream system exceeds a configurable threshold. In the open state, the circuit breaker stops all calls to the downstream system. We don't want to overwhelm our systems. You imagine that we've got our web server and it's trying to hit it there. It's absurd. We want to say, hold off, buddy. Come back in 10 seconds and prevents further strain on the failing service to prevent cascading failures. The open state acts as a protective mechanism, allowing the downstream service to recover without being overwhelmed by those requests. Okay, so now that we've got our retry and our circuit breaker, let's look at cache. Cache is also creates a resiliency because you think about it, if your database is down, you can just cache it and access that. So we cache user details and specific settings for performance and necessity. The cache aside pattern reduces read queries to the Azure Postgres flexible server and provides redundancy for application reliability. Now, caching enhances performance and scalability, offering quick data retrieval and reduces the backend load. Our cache uses Redis, a fully managed in-memory data store for fast, high-performance applications. Now, Contoso decided to use caching abstraction in Springs. It's another little annotation there to improve the performance of their systems. In this example, we annotate the account service class to set the cache settings at the class level with cache config, specifying accounts as the cache name. This allows the application to quickly access updated account information from Redis, reducing the needs for slower database queries. It's lightning fast. So the first time that you go in and you cache the account, it's not as fast as the next time you access it, and it goes straight into memory. And you retrieve it straight out of memory. Similarly, we can see this example that the cache put annotation updates the cache when the update account and set active methods are called. This provides redundancy, keeping parts of the application running if Azure Postgres database has issues and limits the read queries to Azure Postgres flexible server. So how do you load the cache? We're talking about the cache. So we click on the example there. There's an account setting there because like a customer, and you click on the accounts link on the left side menu of the Contosa Fiber application, and you fill out the form and you go add account. This will create an account and store it in the Azure Postgres flexible server. Now, when successful, the account detail page is shown. Using the preview Redis console, we can store this data. We can see this data stored in Redis. Now you can open up the Redis console by navigating to, don't worry, I'm going to do all of this in the demo for Azure Cache for Redis resource in the Azure portal and click on the console link. And then next you can go get com.contosa.cam's account details and one. And you can see there that it's already cached it and we can access it and we can see exactly what we can do. And you can play around with it. You can go in and tune the cache. And we're going to touch that in scalability and performance tuning on how you can actually improve that. So next, let's look at security and cost optimization. So this section, we're going to go through the key areas, the best practices, cost optimization and auto scaling, and how to leverage the Azure service for enhanced performance and security though. So as discussed in our first section here, the reliable web app pattern is really focused on reliability design patterns and more minimal code changes. But to do that, you need ingress security to create a robust and secure application. So how are you going to do that? Well, first of all, we're going to look at how you can have identity-centric security by leveraging off the three main pillars in key areas of security. So what are they? Confidentiality, integrity, and availability. Now, confidentiality means protecting data from unauthorized access, ensuring that sensitive information remains private. Integrity ensures the data is accurate and trustworthy, preventing any unauthorized modifications. And availability ensures that applications are always accessible, even in the face of disruptions. These principles are crucial for maintaining a secure and reliable web application. So how does the reference application leverage off these principles? So let's go into our reference application here, and I've minimized the reference architecture here. So first, the user traffic goes through Azure DNS and is routed via Azure Frontend, which works with Azure Web Application Firewall. This setup keeps the traffic secure and balanced, protecting confidentiality and integrity. Now, next, the Azure Entry ID handles identity management, making sure that only the right people have access, which helps maintain data integrity. Sensitive information is kept secure with Azure Key Vault, adding another layer of confidentiality. Now, when this request hits the Azure Service Plan, access restrictions block unauthorized public access, ensuring further integrity. And then finally, our application logic runs on Azure App Service, which guarantees scalability and reliability, ensuring high available. So yeah, very secure. But we also want to see, okay, cool, Rory, you mentioned managed identity. So how does it do that? And we really leverage off infrastructures of code. Here you can see here, we've got the managed identities already linked in the Terraform code. And in our setup, the system assigned managed identity is configured for the Azure App Service in the Terraform code, and it automatically creates and manages this identity, providing a secure way for the app service to access this other resources. So this setup ensures that the app service can securely interact with resources like the database, the storage accounts, without exposing any credentials. So let's go back in here. Oh, sorry, I think I went a little bit ahead there. So that's the, that's the screen there. I just clicked through there. That's the screen, and you can see there that that's the managed identity. And you can, it's a little tag there. And then you don't have to worry about it. You can define your identities in your Terraform files, and we're going to see exactly how that works in the demo coming up here. Now, identity-based authentication ensures that only authenticated and authorized users can use services and access resources where appropriate. Now, we use Entry ID for this purpose. In the Terraform file, we define the Azure AD application, service principals, and role assignments. Now, we've got roles like account manager, L1 support, and business owner, and they're created and assigned to users. This enforces role-based access control, ensuring that only authorized users can access specific functions or data. If you've got a button there, you don't want anyone to click on it though. Let's just say you want to create an account. We're going to see it in the demo. You only access and you only give it to the account manager. And that is a system assigned managed identity, and that will be authorized and authenticated in Active Directory or Entra ID, and it will flow through to your application saying, this is that person, he's got those permissions, and your code can now go in and perform proper role-based access control. And there are those nice little support settings there. We've got all of those roles there. So managing secrets. So what do you have to do with managing secrets? So it's crucial for doing that, but we have zero trust policy at Microsoft. We don't want secrets flowing around everywhere, like connection strings, API keys, and passwords. So we use Azure Key Vault to store and manage the sensitive information. This is in the Terraform file. So we can click there. You can see there's the Terraform file. And the Key Vault is configured with role-based access control, private endpoints, and diagnostic settings to ensure secrets are stored and accessed securely, though. So, the details such as the Key Vault ID and URL are provided in the Terraform file, and allowing the other service securely reference the Key Vault. And there's the Terraform file there, and it's pretty simple to do. You don't have to worry about secrets flowing through here. So what about cost optimization? So we've got our secure, we've got reliable. So cost optimization is essential for managing expenses efficiently. Now I've got when I go to a customer and they say, why should we go to the cloud? I say to cut costs. They're going, what? You can't cut costs if you go to the cloud. I go, yeah. Now previously what happened is that if you went to a CTO, he would say, okay, cool, we're going to do a projection, 3-year projection, and then right at the end of the 3 year, we're going to tell you how much we're going to spend on our cloud. And I said, no, so not cloud, on our infrastructure. Now, what you can do is you can say, how much can you save? Because what you want to do is you want to take your development environment, you want to really change your development environment from your production environment and see, can you get your production environment to scale accordingly and then cut the costs. So when your production environment isn't under high load, scale it down. So in our example here, we've got the development SKU and the production SKU, and they're configured a little bit differently. And the production SKU actually has high availability for the database. Now, the reference example uses infrastructure as a code to go in and just with a little flag that say, are you deploying production? Are you deploying development? So lower the costs. And we're going to see today I've deployed a development environment, and it costs very little, cents to the months to actually go in and deploy it though. So all of this really is deployed in the Terraform files. You can see here, we've got custom optimization. And if you want to deploy production, it's a little bit of a flag there. And then it will scale up to accommodate your requirements. Lastly, let's demonstrate how to set up autoscaling to achieve cost efficiency. It's one of the new changes that we've done to the application. And now this automatically helps manage resources dynamically based on demand, ensuring that you only use what you need. This helps optimize both performance and costs by adjusting the number of instances according to CPU's threshold. But you can do CPU, memory, a number of users. There's a lot of other different metrics you can do here. In our example here, you go above 85%, guess what? I'm going to add another server. You go down to 65% server, I'm going to drop a server from that there. And auto scaling is actually set up, if you see here, and I actually I did this before. It takes a few minutes to actually go here. We've got the Terraform files to set up the auto scaling. We've got the metrics that actually shows exactly what it is there. And then finally here, you can see there, I scaled up to 6 instances. And then when the usage was down, I scaled down to 6 instances, keeping a maintained, I think this is 1 instance there on my development environment. And this cuts costs quite efficiently, and it makes it very performant. Speaking about performance here, let's go into our next session for performance efficiency. Now you want to, and this is the production environment, you want to actually have operational excellence. In your production environment, and you can see here, I've got two regions. I've got one enabled, and if I wanted to do a cold failover to the other region, I can, and this is the production environment, and that allows you to go in and do a hot cold failover when you want to. So multi-region deployment approach with manual rerouting to secondary regions during your unexpected downtime. This ensures continuous operation and maintains a high level of service. So how do you monitor all of this? It's a lot to take on, Rory. So in the development environment, monitoring focuses on testing and optimizing your code changes before they go live. This includes tracking performance metrics, debugging issues, ensuring that new features do not introduce regression. On contrast, monitoring in the production environment ensures real-time tracking of application performance and availability. You want to see if the people are experiencing a good time on your application. And tools like Application Insights and Azure Monitor are used to monitor key metrics such as response time, error rates, and system health. This helps in detecting and addressing issues quickly, ensuring minimal disruption to service. Let's see how we can actually use those monitoring tools in the next section here. So we've got Application Insights here. Nick, you'll be proud. I actually used, you can see there, it's actually got Nick's instance there. And in this example here, you can click on the exception, you can view end-to-end transactions, and the application map provides a visual representation of the application's components and the interactions. So what we can use for real-time operational excellence, you've got your real-time performance monitoring, and this is the live metrics blade. And this allows for immediate insights into your application's performance and helps in quick troubleshooting. You can monitor real-time metrics. Now we can also revisit our reference architecture and see, okay, I know what it's doing. Can I go in and see, is the cache performing? Because the real opportunity lies in the fact, can you trigger it to be sub-second cache access? You've got your system scaling up. You've got your performance metrics about your database, but we find that the cache is the best way to go in and to tune your application to be hyper performant though. The cache aside pattern, let's go a little bit more detail through this. You can see here, here's the Azure Monitor, and it's displaying the important metrics such as total operation, operations per second, operational rate. And you can actually go into each one of these and you can trigger them and you can monitor them because they provide valuable insights on how well your caching strategy is performing. By regularly monitoring them, you can identify potential issues early and make necessary adjustments to optimize your performance. This ensures that your application is fast, reliable, and responsive. So over here, you can see here, we've got the performance metrics here. There's a lot of metrics. We're not going to go through all of them. You can monitor the CPU from the cache, and you can go to see the latency. Oh, wait, where are we going there? The latency for overburdened. And then you need to do this regularly to make sure that you can say, whoa, we're growing, we're scaling. Now we can actually go in and see, is this working or what's going on here? So in summary, that was a whirlwind tour, but we went through strategies for optimizing costs using non-production environments with cost optimization. We looked at reliability using those design patterns to ensure redundancy across different system layers. We looked at an overview of key security features and configuration using RBAC and also managed identities. And then we looked at security features and configuration and then operational excellence to minimize process variance and enhance operational consistency. And finally, performance efficiency for techniques and best practices for improving caching and overall application performance. Contoso really had a lot of requirements, but these patterns include a reference architecture. I've got a set of videos, I've got a set of workshop, and it takes you from zero to hero if you want to go to the cloud. So next, but Rory, the reference architecture, how do I deploy it? Now you want to do that with a development container. You can go to, this is the setting here, the standard containers.dev. So what happens is if I want to push the reference architecture or my application to the cloud, I want to use dev containers. Now dev containers streamline the development process and they ensure consistency across your environments. They simplify the setup and maintenance of development tools. So we had the Terraform files, which allowed us to use immutable your infrastructure, but development containers do the same for your development IDE and your ecosystem. And it allows you to spin up a container as your IDE in Visual Studio, opening any folder inside a mounted container and defining tools and the runtime stack for development. This benefit includes running applications and separating tools, libraries, and runtimes needed for the code base. So what does this look like here? You just go in, and if you've got a dev container already set up, like we have in our reference architecture, it will say, do you want to reopen in a container? And this is in Visual Studio Code. And you can go in there and it will open up into a Docker instance here. Once you have that, then you want to actually go and follow a set workflow. So AZD init, up, monitor, and pipeline config. And the only ones that we really care about are up, which means push it to the cloud. So we're going to use the Azure Developer CLI. And this follows the best practices, and it's got the key workflow. So better to actually show you what this does. And I've sped this up a little bit. This was one that I pushed earlier. And you can see here, let's just go in and let's go. Okay, we want to just, there we go. You can see here, I'm going to open up into container. And I've got it open up in the container. Now, this is a Docker instance with my IDE. I've got the entire application there. And then I just go AZD up. It connects to Azure. It says, okay, cool. Create the infrastructure that I'm going to do. I've got the Terraform files. I'm going to load up all of those things. What do I need to do in the cloud? If I want to do a Delta, if I want to just make a little change, I can. It's got the application. It goes in there. It creates the application. Then it says, okay, cool. I've got the application installed on Azure. I'm going to deploy your application, which is just a war in Spring Boot. I'm going to deploy that application there, and then I'm going to give you the URLs. Now, it's a little bit sped up, though, but that's how simple it is to actually go in and deploy. And you've got your reference application, Contosa Fiber, already running on Azure. That's a lot to take in, Rory. I hope your demo is going to be really great, but don't worry, it is, because I actually did it beforehand. And now let's go through the demo. The entire demo is actually workshopped. So it's a pretty simple workshop. You can go to aka.ms/RWA workshop. It takes you from 0 to hero. It even helps you set up your development environment. And it's pretty simple here. So now we're going to go out of PowerPoint. Let's just minimize here and make sure that my StreamYard link is here. And now we're going to go through our little demo. I'm running through multiple screens here. You're going to have to give me some benefit of the doubt if I don't do the perfect thing here. Okay, cool. So this is the Contosa reference application, and you can access that. Let's go into there. And this is in the reliable web app pattern for Java. So this is on github.com/Azure. Don't worry, I'm going to give you all of this and at the end here, and /reliable web app pattern Java. Now, the workshop is under workshop folder, and there's also a nice little README that you can follow, and also a demo.md that goes through all of the pattern simulations, which we're going to do right now. Okay, so let's close that off here. So this is the CAMS application, the Contosa Fiber, and you can see here we've got our accounts. So let's go in and create an account, because I want to go in and showcase a lot of these features. So I've got my application here, and I've pushed my application with my development container, and I can go add account here, add Rory here. I'm going to go Rory 2, just to make sure there, and I'll go add account. Found previous account ID 2. Oh, okay. So let's go to there. Let's go add accounts. Okay, there's account 2, and I can click on that, and I can go new support case there. I can go test, add the support case, and I can go click on that support case, and I can escalate to L2, and I can go to click on a site visit, and yeah, I can assign that to me here, and all of this was created in the reference application, and you can see there the reference application. I've got my account controller, which we covered earlier. Now I'm an account manager, so I should be able to add an account. I should also be able to go in and list them, and all of this is actually listed in the Terraform files under the infra, and you can see there under lists there. Oh wow, Rory, you're an account manager. You should be able to go in and add the account where necessary. And yeah, I can get the account there, and I can actually go in there. Now I can see the service plans here. Rory, you said to me you were gonna break something. Okay, cool. The service plans. Oh, wow. Okay. The service plans list just broke right there off the bat. We want to actually go in there and not break it off the bat here. So let's go into there. And let's see what is the circuit breaker actually running here. So let's just go into here. And I had set that up previously. Let's go into here and let's just see. Let's go into there. And I want to see, okay, cool. The retry events. Oh, this is still retrying. Okay, someone, I'm probably me. The circuit breaker is open. Or you do that only at the end of the demo. So let's go back into here. Let's see, and let's wait 10 seconds. And let's go into here. Else, I'm going to switch that off and show you there. So here's CAMs, and here's your service plans. There's the service plans. But I think I had been just before the demo, like clicking it a few times. Now, the service plans here actually have a circuit breaker. So if we go into here and we go into the code, let's go into our service plans here, not account, service plan controller. And we want to see, okay, cool. There's our circuit breaker. And we configured the circuit breaker there to say, hey, everyone, if you hit a number of exceptions, and we're triggering exceptions because we added that little flag there, then go into the a state to say circuit breaker is open, and then go after 15 seconds, see if you can actually get out of there. So let's go break it. So I'm going to hit this a few thousand times. So if I hit service plan here, but if I just go, I'm hitting the mouse like quite a lot here. I should be able to break the circuit breaker. Well, open the circuit breaker here. Let's just see here. Okay, my hands are off now. I've hit that mouse quite a few times here. Now, I don't want to. I want to actually not overwhelm my system. I want to open the circuit breaker. There we go. Circuit breaker is open here. I can go in and see. Okay, cool. Is the circuit breaker open? And I can see, yeah. Circuit breaker is open here. I can go into there, and I can see. Okay, cool. We want to see, yeah, it's 19, and you were not allowed to go further. But if I wait off a little bit, and then I go, okay, cool. I think it was 15 seconds that I had to wait here, and we can play some elevator music there also, and then I can go in there and say, okay, cool, refresh here. There's my circuit breaker. So it really is a pattern of patterns to create reliability. And you saw the enhanced security. But what about the Redis? Rory, the caching. What are you going to do here? So the first thing, I want to go into my Redis cache. And I can see, wait a second. Okay, cool. Let's go refresh here in my application. I want to see, is the cache working? Is it actually triggering here? So I go into here and I go, okay, cool. How much of the cache are we using here? Wow. Okay. The CPU is not that high though, but I want to go into there and see the metrics here. Let's go into view all metrics. And I want to go into the insights, settings. I want to go monitoring, insights. There we go. Okay, so we've got the server load and then the performance, CPU, server load. I want to see the actual cache. There we go. Connected clients, and then expired keys, evicted keys. Yeah, so it's working, but I want to pull that down. Remember that number 2 that we had there? I want to go into my Redis. Let's go back into here, into my console. Let's go into my console there. Let's go into overview. I'm going to console. And now I want to go in and I want to get that CAMS console from the Redis cache live on air though. So if you go into your repo, it actually tells you what to do though. So we want to go into reliable web app, reliable web app pattern for Java. Let's go into there. And in the demo.md, it will tell you about how to do everything that I just showed you here. And we want to go in and we want to get the Redis cache setting to go and say, well, what is actually going on? So we want to go, okay, cool. Here's the details here. And we want to go back into the review cache there. And we want to go Control V. And we want to get number 2. I think number 2 should be cached. Else, let's go. Yeah, there it is. There's my cache. And that is in-memory cache, and it's not going to hit the Postgres database unless it needs to be evicted. Okay, so we've done the circuit breaker. The retry pattern was working in the background any which way. We've done the actual cache. The last thing that we want to do is that we want to bring in our special guest, Nick, who I have really looked forward to do that. So Nick, we have 15 more minutes. Nick is the actual engineer that I partner with, the god of the patterns. Nick's got something very interesting to show you, though. Hey, Nick, how are you doing?
Hi, everybody. Rory, thanks. Great job.
We can't hear you.
Can you hear me now?
Hopefully you can hear me.
I can hear you. How about now? Can you hear me now?
Yeah, we can hear you both.
Oh, you can hear me. Oh, great. Hi, everyone. Rory, nice job presenting the reliable web app pattern. My name is Nick Delalis, software engineer here at Microsoft. As Rory mentioned earlier.
Okay, so Nick seems to be having some audio issues.
No, he's fine.
Nick is coming back, I want to just finish off the links that you can get, and we're going to just show the links that you have here. We'll just wait for Nick to come back here, and we want to do from current slide, which is here. So let's just quickly go through this, and this is the RWA videos. Now, our painstaking, whatever you saw today, I've got a set of really good videos that you can go through there, and that's aka.ms/RWA Java-videos. We've got that awesome workshop that takes you from 0 to heroes. And then we've also got the reference architecture. Not only that, but we've actually got an incredible, and I'm going to, if I can't get through to Nick here, I've got the ability to actually say what Nick was gonna say here. So if I go into reliable web app pattern Microsoft Learn, and it's going to go through, there we go, the reference architectures. We've got the .NET version for you .NETers, which is like the Microsoft version of Java. We've got the Java version. And I brought in Nick because Nick actually is the engineer for all of them, but Nick also is working on the modern web app pattern. So we've got the .NET version, which has just been released. Now, I know, Rory, you're a Java dude. Yeah, but coming up is the Java version of the modern web app pattern. Now, the modern web app pattern actually takes container instances, and you can see there, and you got your container platform. Now, remember what we said? We're going to converge, we're going to modernize, and then we were going to scale. So number 2 is that. Now, if you want to have early access to the Java version, help us test, help us go through some of the niceties of that, please reach out to myself, to Nick. How do they reach us, Nick? They can knock on my door. No, I'm in South Africa. No one can actually get there. Reach out to us. You can reach out to me. My DMs are open on Twitter, which is at Rory Preddy. And then we'll give you early access to the Java version. Obviously, we have to make sure that you're not like one of those fly-by-nighters, non-Azure people that we get occasionally coming in here. No, you can you just reach out to us though, and in there you're going to get the opportunity to modernize your application using container instances there. So reach out to me. My DMs are open. Follow me on Twitter also, or X, or whatever, you know, Elon Musk puts his hands up to actually indicate. He jumps up and he makes an X every single time that we have though, and then help Nick and I test the new version of that and get early access to that though. So those links again, where were we here? Those links again, from current slide. There we go. Get that reference application. Watch those videos. Look at the workshop though. It's really fun to play around with it. And also there's a nice little non-cloud version that I put in there as in the workshop to make sure that you can actually use Resilience for J. So I want to thank you all for coming through to the session here. And I want to thank Nick for the hours and hours of work that he's done with this session though, and bringing in reliability, consistency, enhanced security, managed identity. I could go on for so long about the awesomeness that is that pattern of patterns that is the reliable web app. So thanks everyone, and I look forward to your DMs on my Twitter profile so you can get early access to the modern web app pattern. Thanks everyone. Cheers everyone.
Bye, buddy.
All right. Thank you both. I apologize for that technical issue, Nick, but we appreciate you joining. And thank you all for joining. We appreciate your time today. If you have a moment, we'd ask that you take some time and fill out our feedback survey. And the slide is on the screen. And when you do, please reference the event ID code, which is 23700. Once again, that code is 23700. Thank you. Have a great day, and we will see you next time.